Good morning. Good morning. Hope all is well and everyone's doing okay. All right. Looks like everyone is in. Did anybody, I think we last class we finished out 1.7. So, did anybody have any questions on anything before we go anywhere? Somebody in chat. Good morning. Good morning.
Professor, I have some questions.
All right. Hold on 1 second, letting people in. All right, what you got?
I'm gonna open up one moment.
Mm-hmm.
Is
Sorry,
the test timed?
No, it's not. Mm-mm.
I got the problem right. I just didn't understand the answer. I mean,
Okay.
I understand the answer, but I don't think maybe I missed it.
Okay.
Plus, it says the following ratio equation has a denominator that contains variables. For this equation, write the value. These are the restrictions of variables. Keep the restrictions in mind inside the equation. The equation is 1 over x minus 3
Mm-hmm.
minus the next equation is 5 over x plus 6 equals 9 over x squared plus 3x minus 18.
All right. And so what do they want from you again? The LCD? Or did they want the solution itself?
The first one was what is or the values of variables that makes the denominator 0.
Mm-hmm. Okay. So first thing we'll do is if we look at and evaluate each one of our denominators. First we have x minus 3, the other one is x plus 6. And then this one, we can factor that out to be x minus 3, x plus 6. So that last denominator is a combination of the first two.
Yes.
All right. So we will set each one of them equal to 0. We don't have to do this one if we do both of these, because they're the same expressions. So if you set it equal to 0, solve for x. Both of these values
It's going to be 3 and negative 6.
Yep. So both of those values are values where the denominator is equal to 0. All right. So were you okay with that part? Because I know you don't want to ask no question.
I got that part.
Okay. All right.
And then the next part, it says solve the equation. Select the choice below if necessary. Fill in the blank. They have solution set, which, and then they have solution set is x. I don't know what that little line. X is a real number. And the solution set is, I think that's a 0 and I don't know what the sign is.
Oh, are you talking about this? Or
it's like a 0 with a line across between.
Yeah, like that.
I can't see.
I think. Oh, you can't see it? Hold on. Yeah. Yeah, you can't see that right there. Or some.
Yeah, I can see it.
Okay. Okay. Cool. All right. So that just represents no solution. All right. So LCD here If we're talking about solving this equation, we want to find the LCD so we can clear out the fractions. So the LCD is going to be a combination of each expression that I see. So it's going to be x minus 3x plus 6. Each different expression that we see. So we see x minus 3x plus 6, and then of course x minus 3x plus 6 is a part of that final denominator, so it would just be those two, x minus 3x plus 6. And we're going to take that and multiply it to each numerator. So over 1 and 5. I got everything right. Minus equal. All right, so that's what we're looking at. We're taking that x minus 3, x plus 6, which is our LCD, and we're multiplying to each numerator. I just rewrote that third denominator as that factor expression just so we can make a clean cancellation.
Mm-hmm.
And my stuff not erasing. There we go. All right, so now we can go ahead and cancel out what's in common with the top and bottom. So we x minus 3 cancels in the first one, leaving us with 1 times x plus 6. Next one, x plus 6 cancels, leaving us with 5 times x minus 3. And then in the next one is just 9 because each one of these cancel. All right. Anybody have any questions on anything that's happened so far?
Because I came kind of late, what, this is just like a test review, or?
She just asked a question about a problem that she had a question about. Mm-hmm.
Gotcha.
Yeah. But the floor is open for any questions that anybody has. So I left this 1 there. 1 times anything is itself, but I just want to make sure we were okay with the process. So that's why I left the 1 there, because if that was another number or a different number, then we will, distribute. Same thing here with this minus 5. We are distributing negative 5. That minus stays attached to the 5. So it's x plus 6, negative 5x plus 15 equal to 9. Combine our like terms on the left side. X and negative 5x, negative 4x, 6 and 15.
24.
21, you mean, right?
Yeah.
That's what I did. Okay, cool. Just making sure, you see something I don't see. All right, and that was a positive 9, right? Okay, yeah, we good.
Yep.
So we go ahead and subtract 21. It's negative 4x equal to what? Negative 12. Yep, that would be 12. Yep, I'm good. All right. Then divide by 4. Negative 4, excuse me. X is equal to 3. So anybody have any problems before we go any further? Everybody okay with how we got to 3? All right. So now you make sure that you go back to your 2 values that we could not use. Remember, we cannot use 3 or negative 6 as solutions because they will create 0 in our denominator, which means then I would have undefined. So notice we have x equal to 3, and we just established we cannot use 3. So it means our answer is actually no solution.
Okay. That's what I was missing.
All right. All right. Anything else? Anybody else?
I wanted to know, when we start the test, does it have to be completed in one like sitting session, or is there an option to save like the homework assignments are?
All right. So this is the cheat code on that. Um, now the teacher has a right to not set it up this way. So I wouldn't say try it in other classrooms or in other classes. But I do know students who have taken this and tried it in other classes. Like, yeah, Mr. Tucker, just want to let you know they saw me in the hallway. It worked in the other class. So I'm not telling you to try this in other classes because, like I said, the teacher has the ability to set it up a different way. If you are in a test and let's say you thought you were ready, you're just not, or your brain is fried, and you just like, you know what, I just can't do this right now. The way you do it is that you treat it as if an interruption occurred. In other words, you hit the X button. You don't save it. You don't submit because, of course, there's no way to save it. Then if you hit submit, of course, that's your grade. You don't want to log off or anything like that. You want to treat it as if an interruption occurred. So you'll hit the red X up in the top and shut it down. Just close it out. And then so that's for like in situations, let's say a blackout would occur while you're in the middle of a test or something like that. So that's how you want to treat it. And then what it'll do, it'll let you pick up where you left off. So that's the way to get around that. That's the only way. So like I said, don't try to save it. Don't hit submit. And for safety purposes, don't even try to log out regularly. Just close out, hit the X button in the right corner, and then it should let you pick up where you left off.
Okay, good to know, because I know it's like 30 some questions, and sometimes that's kind of hard to sit and just do all 30 at the same time, all at one time.
Yep, not a problem. Yep. So you have something. Okay, let me make sure I got this right. Somebody wrote a question in the chat, so I'm trying to make sure. All right, so let me know if I've written that correctly. So looking for your chat response. All right, cool. All right. So this is the next one. Someone put in the chat. X to the negative second power plus 6x to the negative first power minus 7 equal to 0. And so here we would use U-Substitution because we have a quadratic, I don't say situation, I'll say quadratic form. You have a quadratic form. Our equation is in quadratic form. So what I mean by that, all right, when we look at this is x to the negative first power squared, and this is 6x to the negative first power minus 7 equal to 0. So whenever we have a situation wherein this right here, the same thing right here, but it's being squared, it is considered to be in, excuse me, quadratic form. Same thing as if I had, simply, let's say, if I had 5x squared plus 7x minus 11 equal to 0. I'm just writing anything right now. Well, x squared is x squared, so it's this right here being squared. So whenever you have that middle term and then look back, the first term is that being squared, then you have your equation in quadratic form. Now the test, that's the main difference between the test and your homework. It does not have the help tools. So that's why you have your test reviews that you can go back to refer to. Make sure that your notes and your studies are streamlined. Tell you what to study for. But yeah, your tests do not have those help tools. So what we'll do is let u be equal to x to the negative first power. So that'd be u squared plus 6u minus 7 equal to 0. So now we have a regular quadratic equation that we can solve for. So I will factor this to u plus 7, u minus 1. set each piece equal to 0. So solving for u, u is equal to -7, and then u is equal to +1. Before we go any further, we're not finished, but before we go any further, questions on how we got here. All right, cool. So now remember, we didn't start off with u, we started off with x. So we're going to back substitute at x to the negative first power n for u. So now we're looking at x to the negative first power is equal to, I can erase this one, erase, there we go, -7, and then x to the negative first power is equal to +1. All right, so we will raise both sides to the negative first power so that we can get rid of the negative exponent off of the x. -1, and whenever you're raising a power to a power, they multiply. So that's why we did that. -1 times -1, of course, is +1. So that'd be x. And then if anything raised to the negative first power, that means you just drop it down into your denominator. So that's going to be x to the x equal to -1/7. Those two negatives don't affect each other. You know, those are two different negatives in two different spots. That's not a negative to a negative. They're not being multiplied, so it's not a negative to a negative turns positive. Your negative exponent drops it down into your denominator, but you know that's still a -7. See something happening in the chat. So that you can cancel out. We raise it to the negative first power so we can cancel out this negative right here. Because remember, your goal is to solve for x. So you don't need this -1 sitting on your x like that. So if you raise it to a negative first power, -1 times -1 will give you just that +1. So when you're raising exponents to each other, they're multiplied. But what I was talking about right here is that these aren't the same negatives. One is a negative in front of your 7. The other one is a negative up in your exponent. So those two negatives don't affect each other in the same way. All right. So hopefully that answered your question. If not, feel free to let me know. And then, of course, 1/1 is just 1. So those would be your two answers. All right. Now 3 times 2. Oh, okay. Okay, I think I see what it is. But okay, so before we go to the next problem, if someone is presented, questions on this one. Any question? Great. All right, everybody good before we go to the next one? All right, so going back to the chat. Make sure I write this correctly. All right, so is that how you wanted or how the problem is? Oh, so it's equal to -78? Okay. All right. So we have 3x² - 3 equal to -78. So first thing we'll do, we're trying to solve, excuse me, we're trying to solve for x. So we need to get x by itself. Sorry, trying to cut this off. So we want to isolate that x. First thing we can do is add 3 to both sides. So that's 3x squared equal to negative 75. Divide by 3. X squared is equal to negative 25. Now we need to get this square off of x. So we'll take the square root of both sides. The square and square root will cancel, leaving us with just x on the left. Then on the right, whenever you take the square root of both sides, don't forget the square root property, which means I need to have plus or minus. Then the square root of a negative number always going to result in I. So don't forget the square root. It's going to be imaginary. So that would be 5i. So our result should be plus or minus 5i. All right. Is that okay? Any questions on that? All right. Any other questions?
It's kind of like a not. I just don't really understand like putting words into equations that well. Like I'll kind of get lost.
Do you have a problem?
Just like word problems in general, like where you have to find out how do you solve this and like write it out.
Let's see if I can find one and don't have my stuff pulled up. All right, so let's look at this one. It says a new car worth $27,000 is depreciating in value by $3,000 per year. It says write a formula that models the car's value Y in dollars after X years. So this is something like you're talking about?
Yeah, like that.
Okay. So A new car worth $27,000 is depreciating in value by $3,000 per year. What are my notes? So we're talking about writing down our given pieces of information first. Car's worth is $27,000. Depreciates per year by, I think it was 3,000. Yep, by 3,000. So we're going to write an equation that represents that. Let me see if they have something else. Okay, that's the other part. So first part they want us to do is a formula that models the car value Y in dollars after X years. Okay, so we're saying they gave us in A, they gave us that Y is our dollars, X is years. So Y is going to equal dollars, and it's the car value after X years, and of course X years. So X is going to represent years for us. So the car starts at 27,000, and it's going to depreciate. Since it depreciates, that means it's going to be negative, a negative effect. So we're going to do minus $3,000, and you're talking about per year. So $3,000 every time X turns to the next year. So currently, right now, $27,000. If no years have passed, that's how much it's worth, $27,000. In other words, no years passed, that means that's zero. If you add, make that 1, then that's going to be 3,000. So you subtract 3,000 from it. You make that 2, 3,000 times 2 is 6,000. So you subtract 6,000 from it, and so on. So that's why you do 3,000 times X. Once again, it says depreciates. So that's why you're using this minus sign here. Now, if it said appreciate, then it would have been positive, because it means it would be going up. So it's always going to be keywords that's going to dictate what operations you use. And, going back to the X, 3,000X, when it said per year, you know that 3,000 is going to be multiplied to whatever variable you're calling your year. And it's going to be equal to Y, after however many years, this is how much the car is going to be worth. All right, so did that make sense? Is that okay? So make sure.
Yeah.
Okay.
I see.
And see what it asks for next. Use the formula from part A to determine how many years the car's value will be in 12,000. Do something real quick. Minus. So they give us 12,000. Yep. Hold on, they word that a little different. Use the formula part A to determine how many years. Okay, so this time what they give us is 12,000 as far as the car value. And they want to know how many years.
So 12,000 is the Y.
Mm-hmm. Yep. So that's what we'll do. We'll plug in 12,000 for Y and then solve for X. So we're minus 27,000. So that'd be negative 3,000. Make sure you don't lose that negative. That's negative 15,000. There you go. And divide by negative 3,000. And X will be 5. So in 5 years, it will be worth $12,000. All right. All right. Any questions on that one?
No, I got it. Thank you.
Mm-hmm. So we'll do one more just to make sure, we're okay. Looking at this one, all I did was just choose the next problem. But, when it comes to these word problems, sometimes a specific word problem could be an issue just because of wording and stuff. So, if you try another one out and, you
I
get
think
stuck
this
on
was the one that I think gave me a little bit of more problems on the homework.
it. Okay. Yeah. So, but yeah, if you come across one that runs a little trouble, always feel free to bring that one, to class and we'll talk about it. So, here it says you are choosing between two health clubs. Club A offers membership fee for $11 plus a monthly fee of $12. Club B offers a membership of $20 plus a monthly fee of $11. How many months will the total cost for each health club to be the same? What will that total cost for each club be? So let's look at our givens. So we have 3 algebraic representations that we're going to need. So we need a representation for X. So we need an X, and our X is going to be monthly or per month, just like last time X was per year. But this time we're talking per month. And going back to Club A. Club A offers membership fee of 11 plus monthly fee of 12. All right. So we got $11. That's the initial fee. Plus, right? You looked at it right. A month membership fee of 11 plus monthly fee of 12, right? So that's going to be 11 plus 12x. If I remember correctly, Club B was 20 plus a monthly fee of 11. Yep. So that's how we set that up. Or at least that's how we establish our unknowns. We had 3 unknowns. All right. So now this one says, after how many months will the total cost of each health club be the same? So the key word here is the same. So setting up this equation, I want to know when will these two expressions, Club A and Club B, be equal to each other. So, all right. So you go ahead and solve for X. Subtracting 11x from both sides. Subtracting 11. X is equal to 9. So in 9 months, they will be the same. And so just making sure we're clear on what we're saying happened here. The initial payment for Club A was only $11, but the initial payment for Club B was $20. So, off the top, Club B costs more than Club A, but Club A would charge you $12, which is $1 more than Club B monthly. So at some point, Club A is going to catch Club B and then pass it. So, and then it would be to your benefit if you're going to go past a certain amount of months that you would do Club B versus doing Club A. And so that's what we're looking at. At what month are they going to be equal to the same amount of money? And then, so that basically say, okay, if I'm going to be in this club longer than 9 months, then I should do Club B, because even though I'm paying $20 more or $20 extra initially, Club A is going to cost me more in the long run. You know, if I stay with the club longer than 9 months. All right. And then I think you asked one more question. What's the total cost for each health club? So then you would just take that 9 and plug it into either one of those expressions, Club A or Club B. Doesn't matter. Because remember, they're going to equal the same at 9 months. So it should be 119. All right. Any questions? Any questions?
I'm getting it. I'm getting it.
Okay, cool. All right. Anything else? Anybody else? Anybody have a certain type of problem they want to see me do? Everybody straight? Everybody okay? All right. So, so you guys have chapter 1 and test 1 at your disposal now that we are expecting you to, knock out as soon as possible. Anything, once again, I post in my math lab. You do have till August 8th to do, but just remember, no, this class, I keep saying that, I keep forgetting y'all not statistics. You guys have until the 20th. Y'all actually have an actual due date. Only reason I have to do y'all class like that because everything builds upon the next. In statistics, a little more flexibility. But you guys have to knock yourself out by the 20th. Now, don't forget, if issues come up, if something prevents you from doing so, make sure you communicate with me so we can try to work something out. If my math lab go down that weekend, the server go down or something like that, I won't know unless you tell me. You know what I mean? So, make sure you keep lines of communications open so that I can make adjustments to your benefit accordingly. And once again, if you have an individual situation, make sure you address me individually versus, saying something in front of the class in which I would have to give you a class answer. So that's always the case whenever you deal with any instructor. If you have an individual situation, always make sure you ask that instructor individually, so you can't get an individual response to your situation. All right. So, like I mentioned, we do have to at least, let me see. Yeah, that's 2-2. Yeah. So let's at least do 2-1 today. And call it a day. All right, so 2.1 is basics of functions. And I have to, you see what I have in red, I have to switch pages, but I'll give you a chance to write down the title. All right, basics of functions. All right, why don't I see my, okay. All right, so let's look at functions. First thing we're going to start off with is the definition of a relation. And a relation is any set of ordered pairs. So an example I have here is 1, 2, 3, 4, 5, 6. You have 3 ordered pairs. A relation is any set of ordered pairs. All right. Your domain is a set of all the first components of your ordered pairs. In other words, your x values in this case. So we're looking at 1, 3, 5. course, if I scroll up, somebody still copy and let me know. Now your range is a set of all of your second components of your ordered pairs. That would be your Y, 2, 4, 6. All right. All right, so here's a clear comparison, a clean comparison between the two. Am I still copying range? All right, so your domain versus your range, like I just mentioned, first component versus second component, X variables versus your Y variables, input versus output, independent variable versus your dependent variable, and then your domain will be your horizontal axis when your range will be your vertical axis. Everybody okay? All right, so definition of a function. A function is a relation in which the elements from the domain corresponds to exactly one element in your range. All right, so let's talk about what that means. Once again, function is a relation in which the elements from the domain corresponds to exactly one element in the range. So here in the red, first example, tell us to determine whether each relation is a function. So let me erase this. All right, so we have 1, 6, 2, 6, 3, 8, and 4, 9. And we want to determine whether this relation represents a function or not. So we will go back to the definition, make sure we're clear on what the definition says of what a function is supposed to be. Each element in the domain goes to exactly one element in the range. So what we'll do is create a mapping. That's what I did right here, my domain and range. Over here, all of my values in my domain, 1, 2, 3, 4. Over here, all of my values in my range, 6, 8, and 9. So we'll look at each one of the elements in the domain individually, see if they fit the description of a function. So in other words, each value in the domain goes exactly to one element in your range. So does 1 go to one element? The answer is yes, it's number 6. Does 2 go to one element? The answer is yes. Even though it goes to the same element that 1 went to, we're just talking about 2. Does 2 go to one element? The answer is yes. Does 3 go to one element? Yes. Does 4 go to one element? The answer is yes. Since all of those are yes, then yes, it is a function. All right, questions on that one before we look at the next one? So you just evaluate and look at each one of the elements in your domain individually and say, does that one element go to just one element in the range? All right, anybody still copying that?
For the range, I'm just curious, like, would it still work if you just listed 6, 6, 8, 9 versus, you know?
But normally you don't repeat it if they don't really see it. Yeah, they really don't see it as necessary to repeat it. Normally, yeah, if you have a repeated value, you just write it at one time. Mhm.
Okay.
All right, so somebody from that class just asked the general questions. So let's look at this one. Say if we had 61628394, and we want to know, does this represent a function? So you want to do the same thing, create your mapping. You see this time my domain is 689, my range is 1, 2, 3, 4. And you look at each element in your domain individually and ask that question that we just finished mentioning. Does each element in your domain go to exactly one element in the range? So you look at the number 6. Notice it goes to 1, but 6 also goes to 2. So the answer is no. And so that stops it from being a function. Mhm. Questions? Any questions? All right, I'll scroll up. Is everybody okay? So in the blue, just some general statements about what we just saw, what we just witnessed through those two examples. You can say there could be a repeated value in the range, but no value can repeat in the range. No value can repeat in the domain, and that's what we had here. Notice we had the first one, 6 was repeated in the range, but then here when 6 was repeated in domain, it ended up not being a function. So that's what I mean by that. There can be a repeated value in the range, but no value can repeat in the domain and it still be a function. Second statement, just another way of saying it, the range can go to more than one value. The domain can only go to one value. Any questions? Anybody still copying before we go to the other set of notes? All right. All right, the next way that it could ask you to determine whether you have a function or not is this way. So here they give us an actual equation, and then we have to go about determining if that it is a function. So here it says determine whether each is an equation that defines y as a function of x. So the first one we're looking at is x squared plus y equal to 4. So the first thing we'll do is take our equation and solve it for y. So we had x squared plus y equal to 4. Subtract x squared from both sides. Y is equal to 4 minus x squared. Any problem with the first step? All right, so the next one, we're going to evaluate to see if multiple y values can be produced. And so what I mean by that, and you'll see how that can occur in the next one and see the difference between the two. But basically, when you plug in values for x, and that's what I did here, I said just choose 1, -1, 2. When I plug in values for x, will more than one value be produced? We're not talking about is it going to go to the same value or the same number will be produced. Will more than one value be produced? And the answer is no. There's no way for me to plug in 1 and get out more than one value. Like I said, just hold on tight. You might ask yourself, well, when can more than one value be produced? Just sit tight. The next one to show you what we mean by more than one value being produced. But this is a function. No matter what value I plug in, if I plug in 5, I'm only going to get one number out. If I plug in 3, I'm only going to get one number out. No matter what I plug into this equation, I'm only going to get one number out. And so that's why this is a function. All right, everybody done copying before we look at the next one. I scroll up, everybody good? All right, so what's gonna set B apart from A is this point right here. We have x squared plus y squared equal to 4. There's an even power on y. So if that was y to the 4th, y to the 6th, y to the 8th. If you have an even power on y, this will end up being your result. All right. So once again, we're going to solve for y. But when I go to solve for y, I need to take the square root of y in order to get the square off of y. You know, notice we subtract the x squared from both sides. Got y squared equal to 4 minus x squared. Then I have to take the square root. And so whenever you take the square root of both sides, don't forget the square root property will be what has to be implemented. So whenever you take the even root of both sides, you know, that square root property, that plus or minus has to be implemented. And this is what's going to cause us to get more than one value. So the key here, once again, is do you have an even power on your y? And that's going to cause us to have to implement this plus or minus. I'll give you a chance to finish copying it. All right. So now if I just take positive 1, if I would plug in positive 1 to the equation for x, that's 4 minus 1 squared. 4 minus 1 is 3. But the main thing that is causing us the problem is the fact that we have plus or minus right here. So that when I plug in 1, I get plus or minus square root of 3, which is 2 different numbers. So if we were to do our mapping, that means 1 would go to positive square root of 3, 1 would go to negative square root of 3. And once again, all of this was implemented by the fact that, or initiated by the fact that we have an even power on our y. So in the blue, you see x produce 2 y values. That makes it not a function. All right, questions? Any questions?
Yeah, I have a question because I'm a little confused of where you're getting the X value 1. Are you just like coming up with it because it's 1? Like, I don't
You
get.
just choose it. Yep.
Okay, that's what I figured. I just wasn't sure if I missed like a step.
No, you're fine. Yep, you're just choosing it, trying to test test the outcome of that equation. Yep. 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 Could have chose 5. You could have chose 5 million if you wanted to. Yep. All right. Anything else? Anybody else? Before we scroll up, make sure we're good. All right. Okay, vertical line test. If any vertical line crosses or touches a graph more than once, it is not a function. All right, so just looking at a few of them. If I have a circle and I draw a vertical line through it, it's going to touch it twice. So that means it's not a function. You know, once again, if a vertical line touches or crosses a graph more than once, it is not a function. If I have a linear equation, just a straight line, no matter where I draw my line, it's only going to touch it once. So that means it is a function. Same thing with the parabola. No matter where I draw a vertical line, it's only going to touch it once. That means it is a function. Then this fourth one, this last diagram, even though over here, no matter where I drew my line, it only touched it once. But when I get over here, it touches it 3 times. So that means it is not a function. So once again, if any vertical line crosses or touches the graph more than once, it is not a function. All right, questions? Any questions? All right, can we scroll up? Good. All right, so function notation, I believe is the last thing we're talking about in this section. So y is equal to f of x. That's how you say that. F parentheses x is f of x. So y equal to f of x. So what this is saying is that y and f of x are interchangeable. You could be in the middle of a problem. They can switch to f of x, switch back to y, and not, be unapologetic about it. because they just assumed at this point forward, you know the f of x and y are the same thing. F of x and y are the same thing. So if my equation, I still have my eraser on, of course, but if my equation is y equal to 2x plus 1, and I want to write it in function notation, I will substitute f of x in for y. And now this function right here is considered in function notation. All right. So what this does for us is it gives us instructions. So if they told us to find f of 3, and even if, and the reason why I had that scratched out, even if they didn't say find f of 3, let's say if the find wasn't there, and all you wanted to do was know what f of 3 were, you would know how to do that because you would go to your f function. Now, f of x has to be defined first. You can't find f of 3 if there is no f of x. So your function has to be defined first, and then it just tells us to plug in 3 where you see x in the function. And so that's all it is. It's just instructions on what to do if you want to figure out what the outcome would be if you were to plug in a certain number. So that's what I did right here, plugging in 3 into the function. That's 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. So f of 3 is equal to 7. Also, that means that our ordered pair, if we want to pull an ordered pair from that, when I plug in 3, I get out 7. That means 3 is x, and 7 is our y. All right. Questions on what we did there? Make sure we're all right. And over here, I just mentioned it doesn't have to be f of x. It could be g of t, s of r. It can be any m of n, but they will define it for you, and you'll know what values to plug in, versus what should be getting out. So. All right, everybody okay before I scroll up? All right, so here it says if f of x is equal to x squared plus 3x plus 5, find f of 2, then find f of x plus 3. So once again, notice they defined f of x first. So you don't have to go looking for it or trying to figure it out. Then A is find f of 2. So you're going to plug 2 into the function wherever you see x. That's what we did right here. So that's 2 squared plus 3 times 2 plus 5. 2 squared is 4. 3 times 2 is 6. Add those together. That'll give us 15. All right. Everybody okay with A? Okay, now B says plug in x plus 3 in for x. So you're plugging in that whole quantity. And that's what I did right here. So wherever I saw x, I put x plus 3. So that's x plus 3 squared plus 3 times x plus 3 plus 5. So everything's still the same. It's just that instead of x, you see x plus 3. All right, so make sense of what we got going on here. So the first thing we had to do is expand x plus 3 squared. That is x plus 3 times x plus 3. And that's what I did right here. I think I'll go back to blue. And so that's your binomial distribution, x times x, x times 3, and 3 times x, 3 times 3. And so that gives me this part right here, x squared plus 6x plus 9. All right. Then we'll distribute 3 And that gives us this part, 3x plus 9. And then, of course, the 5 is still back here. All right. And then combine your like terms. 6x and 3x gives you 9x. Then 9 plus 9 plus 5 will give you 23. All right. Questions? Any questions? All right. Everybody good? Everybody straight? That's it for 2-1. So, any questions on anything I've said up to this point? All right. So try the stuff out. You know what you guys have to do as far as chapter 1 is concerned. Next class, feel free to ask questions. And so I'll do whatever I can to make sure you guys straight moving forward. All right. So you guys have a great weekend. Be safe. And I will see you on, hold up. This is Thursday. See you on Tuesday. See you on Tuesday. You guys have a good one.
Thank you, Professor. Have a good one.
Thanks. You do the same.
Enjoy the rest of your day.
You have a nice day.
You do the same.
Have a nice day.
Thank you. Thank you. Take care. This man. Okay.